Welcome to quicktechie.com, Palo Alto Networks, Network Security Generalist Certification Training. Let's dive into next module.
SSL Forward Proxy Role. Okay, let's talk about the SSL Forward Proxy Role. Imagine your employees inside your network are trying to visit a secure website, like an online store or a secure banking site. When they go to a website address that starts with HTTPS, their computer creates a private, encrypted connection. This uses a technology called SSL, TLS, directly to that website on the internet. Think of this as putting their message in a locked box that only their computer and the website's server have the key to open. SSL Forward Proxy means that your Palo Alto Networks firewall steps in and handles these locked boxes, the encrypted traffic, when they are going out from your internal users towards the internet. The firewall doesn't just let the locked box pass straight through. It intercepts that outbound encrypted traffic. It catches it before it goes directly to the external server. When the firewall intercepts this traffic, it places itself in the middle. It acts as an intermediary or a proxy. Instead of the employee's computer talking directly to the website server, the employee's computer talks to the firewall, and the firewall then talks to the website server. And when the website server sends data back, it sends it to the firewall, and the firewall sends it back to the employee's computer. So, the firewall is sitting right in the communication path, handling the encrypted conversation on behalf of the internal user. This position as an intermediary is the key step that allows the firewall to do more with this encrypted traffic, which we'll discuss next. Intercepts outbound encrypted traffic. Okay, let's explain. Identifies applications traversing the network, regardless of port or protocol. Imagine network traffic like different kinds of vehicles driving on roads. Traditionally, security devices would mostly look at the road or lane the vehicle is using. That's like the port number. For example, port 80 often means web traffic, and maybe if it's a car or a truck, that's like the basic network language or protocol, like TCP. But today, many different types of vehicles, applications, can use the same road or lane. For example, both a normal website visit and someone using a file-sharing program might use the same port 80 or port 443 for secure traffic like HTTPS. Also, some applications might try to hide by using a different road than expected. Identifies applications traversing the network, regardless of port or protocol, means that Palo Alto Networks App ID technology doesn't just look at the road or lane, port, or the basic vehicle type, protocol. Instead, it looks inside the vehicle to see exactly what kind of application it is. So, even if a file-sharing application like BitTorrent is trying to use port 80, which is normally for websites, App ID can identify it correctly as BitTorrent. It doesn't just say, port 80 traffic, it knows the application name. This ability to identify the application accurately, no matter which port or basic protocol it uses, is the core of App ID. It's like knowing if it's a sedan, a delivery truck, or a sports car disguised as a sedan, regardless of which road it's on. This precise identification is the first crucial step for better security. Positions the firewall as an intermediary. Okay, let's focus on what positions the firewall as an intermediary means in the context of SSL Forward Proxy. Normally, when you visit a secure website, HTTPS, your computer talks directly to that website's server on the internet. They establish a secure, encrypted connection just between the two of them. With SSL Forward Proxy enabled, the Palo Alto Networks firewall changes this direct communication. When your computer tries to start that encrypted connection to an external website, the firewall intercepts it, as we discussed. But then, it doesn't just look at it, it actively takes over the role of talking to the website. Think of the firewall becoming a go-between or a middleman. 1. Your computer starts an encrypted conversation, but it talks to the firewall. 2. The firewall then starts a separate encrypted conversation with the actual website server. 3. When the website server sends information back, it sends it to the firewall. 4. The firewall then takes that information and sends it back to your computer using the encrypted connection it has with your computer. So, the firewall is sitting right in the middle of the conversation. It's like if you wanted to send a secret letter to a friend far away, but instead of sending it directly, you give it to a trusted person, the firewall. That person then writes a new letter, maybe using their own secret code, to your friend, and when the friend replies, they reply to the trusted person, who then sends the reply back to you. By positioning itself as this intermediary, the firewall effectively breaks the single, end-to-end encrypted connection between your computer and the website into two separate connections, one between your computer and the firewall, and another between the firewall and the website. This setup is necessary so the firewall can open the locked box, decrypt the traffic coming from both sides and see what's inside, which is the main goal of SSL decryption. Purpose for security. Okay, let's talk about why Palo Alto Networks uses SSL forward proxy and decrypts traffic. The main reason is security. Think about encrypted traffic, like HTTPS websites. It's like data is put into a sealed, locked box. This protects your privacy, which is good. But it also means that if something bad is inside that box, like a virus, a harmful website link, or instructions from an attacker, your security devices can't see it because it's locked away. The first security purpose is that decryption enables visibility for App ID. Remember how App ID needs to look inside the traffic to identify the application. If the traffic is encrypted, App ID might only see encrypted traffic, or SSL, and can't tell if it's normal web browsing, a risky file-sharing app, or something else specific. By decrypting the traffic, App ID can see the actual data and accurately identify the application, even if it's hiding behind encryption. Second, decryption allows other security services to inspect the content. Once the locked box is opened, decrypted, other security engines on the firewall can look inside. This means services like threat prevention can scan for malware signatures in downloaded files. URL filtering can see the actual website address being visited to check if it's a known bad site. WildFire can analyze suspicious files or traffic patterns found inside the decrypted stream. Without decryption, these services would be blind to a huge amount of traffic, making them much less effective. Finally, this ability to inspect the decrypted content is crucial for detecting hidden threats. Many modern attacks, like malware downloads, attempts to exploit software weaknesses, or secret communication with infected computers, command and control, are hidden inside encrypted traffic from legitimate applications. By decrypting, the firewall can find these malicious activities that would otherwise sneak past undetected within what looks like normal, secure communication. So, the security purpose of SSL decryption is to remove the blind spot created by encryption, allowing App ID to work correctly and enabling deep inspection by other security services to find and stop hidden threats. Enables visibility into encrypted traffic. Okay, let's talk about how SSL decryption enables visibility into encrypted traffic. Imagine network traffic is like letters being sent. Encrypted traffic, like when you visit a secure website using HTTPS, is like a secret letter sealed in a strong, locked envelope. Only the person who sent it and the person who is supposed to receive it have the key. Without decryption, your security firewall only sees the outside of this locked envelope. It knows where the letter came from and where it's going, source and destination IP addresses, maybe the port number like 443 for HTTPS, but it cannot read what's inside the envelope. The problem is, the application information and any hidden threats are inside that locked envelope. Enables visibility into encrypted traffic means that the Palo Alto Networks firewall, by performing decryption, opening the locked envelope, can now see and read the contents. It turns the scrambled, hidden data into plain text that can be understood. Why is this visibility important? Primarily for App ID. Remember, App ID needs to look at the data to figure out the exact application? If the data is encrypted, App ID might just see SSL, or encrypted web traffic. But once decrypted, App ID can see the specific patterns and language of the application. For example, many different applications use HTTPS on port 443, normal web browsing, but also file sharing like Dropbox, video conferencing like Zoom, social media like Facebook, etc. If the traffic is encrypted, without decryption, the firewall might just lump it all together as SSL or web. But after decryption, App ID can see the difference and identify it correctly as Dropbox, Zoom, or Facebook. This ability to see inside the encrypted traffic is the crucial first step. It provides the necessary visibility for App ID to work accurately on encrypted connections, which make up a huge portion of internet traffic today. Without this visibility, App ID would be much less effective. Allows inspection of encrypted content. Okay, let's focus on allows inspection of encrypted content. We talked about how encrypted traffic, like HTTPS, is like a locked box where the data is hidden. Before decryption, security tools couldn't see what was inside this box. This point means that once the Palo Alto Network's firewall performs SSL, TLS decryption, which is like opening that locked box, the information inside the traffic is no longer secret or scrambled to the firewall. It becomes readable, or clear text. Now that the content is clear, other important security services on the firewall can actually inspect it. Think of these services as specialized security checks, threat prevention. This service looks for known bad patterns, like signatures of viruses or malware, or signs of attack attempts, exploits. It can now scan files being downloaded, or data being sent, within that previously encrypted traffic. For example, it can find malware hidden inside a file downloaded from an HTTPS website. URL filtering. This service checks the website address. Even if you are going to a bad website over HTTPS, the address is hidden in the encrypted traffic. After decryption, the firewall can see the full URL and block you from going to a known dangerous site. WildFire. If the firewall sees something suspicious that it doesn't recognize, like a new file, it can send it to WildFire for deeper analysis. This analysis needs to see the actual content, which is only possible after decryption. So, in simple terms, SSL decryption allows the firewall's security engines to finally look inside the encrypted conversations. This is essential because it makes all those powerful security services effective against the majority of internet traffic today, which is encrypted. They can now inspect the actual application data to find and stop threats that are trying to hide. Crucial for detecting malware, exploits, and command and control. Okay, let's talk about why SSL decryption is critical for finding really dangerous things like malware, exploits, and command and control traffic. Imagine the bad guys sending harmful stuff to your computers. They know that security systems are watching. So, they often try to hide their attacks by putting them inside traffic that looks totally normal and safe. And today, most normal traffic, like visiting websites, using cloud apps, or file sharing, is encrypted, like using HTTPS. This encryption, while good for privacy, is also a perfect hiding place for attackers. It's like hiding something bad inside a sealed, locked box that the security guard can't open. The point, crucial for detecting malware, exploits, and command and control, means that without being able to unlock and look inside this encrypted traffic, your security system will likely miss these hidden threats. Here's why decryption is so important for these specific threats. Malware. Viruses and other harmful software are often downloaded from websites or transferred through cloud storage apps, which use HTTPS. If the traffic is encrypted, the firewall can't scan the file content for malware signatures. Decryption lets it see the file and find the hidden virus. Exploits. These are special pieces of data designed to break into software by finding weaknesses. Attackers send these exploit payloads hidden within normal application data streams, often over encrypted connections. Decryption allows the security engine to inspect the data stream and detect these malicious patterns. Command and control, C2. This is how attackers control computers they've infected. The infected computer might talk back to the attacker's server using encrypted connections that look like normal web browsing, HTTPS, or other allowed applications. The actual messages, the commands and stolen data, are hidden inside. Decryption reveals these hidden messages, allowing the firewall to identify the C2 communication and block it. So, SSL decryption isn't just about seeing what applications people are using. It's absolutely necessary to remove the hiding place that encrypting traffic provides to the most serious threats. Without decryption, a huge percentage of malware, exploits, and C2 traffic would pass straight through your security, undetected. That's why it's crucial. Mechanism on PANW platforms. Okay, let's explain how the Palo Alto Networks devices actually perform this SSL forward proxy decryption. It's a clever mechanism. Remember we said the firewall acts as an intermediary? When your computer wants to connect to a secure website, like https://www.example.com, it usually checks the website certificate to make sure it's real and trusted. This is normally signed by a well-known certificate authority, like DigiCert or Let's Encrypt, that your computer already trusts. With SSL forward proxy, the Palo Alto Networks firewall does something different. To make your computer trust the firewall as the intermediary, you first need to install a special Trusted Root Certificate Authority (CA) certificate from the Palo Alto Networks firewall onto all the computers, client devices, in your network. Think of this like giving your computer a special Trust Pass for the firewall's certificate-making ability. Now, when your computer tries to go to https://www.example.com, the connection goes to the firewall first. The firewall doesn't just pass the website's real certificate to your computer. Instead, the firewall dynamically generates certificates on the fly, specifically for the website you are visiting, www.example.com, in this case. It creates a new certificate that says, I am www.example.com, but this fake certificate is signed by the Palo Alto Networks root CA that you installed earlier. Because your computer trusts the Palo Alto Networks root CA, it sees the firewall's fake certificate for www.example.com, checks that it's signed by the trusted CA, and says, okay, this connection is trusted, even though it's actually talking to the firewall, not directly to the real website. This allows the encrypted connection to be established between your computer and the firewall. The firewall then establishes its own separate encrypted connection to the real www.example.com server. This mechanism, using a trusted root CA and dynamically generating certificates, allows the firewall to sit in the middle, decrypt the traffic from your computer, inspect it, and then re-encrypt it before sending it to the destination server, and vice versa. This same technical process is used consistently whether you are using a physical Palo Alto Networks firewall, Strata, or a cloud-based service, SASE, ensuring the decryption and inspection work the same way everywhere. Uses a Trusted Root Certificate Authority, CA, certificate. Okay, let's explain. Uses a Trusted Root Certificate Authority, CA, certificate. When you visit a secure website, HTTPS, your web browser checks the website's security certificate to make sure it's real and that the connection is secure. These certificates are usually issued and signed by companies called certificate authorities, CAs, like DigiCert or Let's Encrypt. Your computer already has a built-in list of CAs that it automatically trusts. If a website's certificate is signed by one of these trusted CAs, your browser shows a lock icon and you feel safe. Now, remember how the Palo Alto Networks firewall acts as an intermediary in SSL forward proxy? It intercepts your connection and creates a new certificate for the website you're visiting. If the firewall just created a certificate out of nowhere, your browser wouldn't trust it because it's not signed by one of the CAs on its built-in trusted list. You would see a big warning message saying the connection is not private. To make this work smoothly without warnings, you need to tell your computers to trust the firewall's ability to create these certificates. You do this by installing a special Root Certificate Authority, CA, certificate from your Palo Alto Networks firewall onto all the computers, client devices, that will have their traffic decrypted. Think of this root CA certificate from the firewall as adding a new, trusted name to your computer's list of official ID card issuers. Now, when the firewall generates a certificate for https://www.example.com and signs it with its own root CA certificate, your computer checks the signature. Since you installed the firewall's root CA on your computer and it's now on the trusted list, your computer says, okay, this certificate for www.example.com is signed by a trusted source, the Palo Alto Network CA, so I will trust this connection. This step of installing the trusted root CA certificate is essential because it makes the client devices trust the firewall's role as the intermediary and allows the encrypted connection to the firewall to be established without security warnings, enabling the decryption process to happen transparently to the user. Firewall dynamically generates certificates. Okay, let's explain what firewall dynamically generates certificates means. Remember how, when you visit a secure website, HTTPS, your browser expects a security certificate from the website to prove it's real. In the normal process, the website sends its actual certificate, signed by a public company like DigiCert. Your browser trusts DigiCert, so it trusts the website. With Palo Alto Network's SSL forward proxy, the firewall is the intermediary. When your computer tries to connect to a secure website, let's say securebank.com, the firewall intercepts that connection. The real securebank.com server is still out on the internet. The firewall needs your computer to establish an encrypted connection with the firewall first. To do this without your computer showing a security warning, the firewall performs a clever step. It dynamically generates a new security certificate right at that moment, specifically for securebank.com. Think of it like this. The firewall creates a temporary, fake ID card for securebank.com. This fake ID looks like it's for securebank.com, but instead of being signed by the real bank, it's signed by the special Palo Alto Network's root certificate authority that you previously installed and trusted on your computer. Because your computer trusts this Palo Alto Network's root CA, when the firewall presents this dynamically generated certificate for securebank.com, signed by its own trusted CA, your computer accepts it as valid. So, dynamically generates certificates means the firewall doesn't store a copy of every website's certificate. Instead, for each new secure website connection it intercepts, it quickly creates a new certificate for that specific website's name and signs it with its trusted key. This allows the encrypted connection to be successfully set up between your computer and the firewall, paving the way for decryption and inspection. Applies decryption and inspection consistently. Okay, let's explain. Applies decryption and inspection consistently. Imagine your organization has different ways people connect to the internet or access applications. Some might be in the main office, protected by a physical Palo Alto Network's firewall. This is part of the Strata platform. Others might be working from home or using a cloud service, with their security provided by a cloud-based service like Prisma Access or Cloud NGFW. These are parts of the SASE platform. The challenge is making sure that no matter how or where someone connects, they get the exact same level of security protection. Applies decryption and inspection consistently means that the process of handling encrypted traffic, like HTTPS, and then checking it for threats works in the same way and provides the same results across all these different places, on the physical firewalls, Strata, and on the cloud security services, SASE. Here's what that consistency means. 1. Consistent decryption. The SSL forward proxy mechanism, where the firewall acts as an intermediary and decrypts the traffic, uses the same steps and logic whether it's happening on a physical firewall or in the cloud. The process of using the trusted root CA and dynamically generating certificates is the same. 2. Consistent inspection. Once the traffic is decrypted and visible, the security engines, App ID for identifying applications, threat prevention for finding malware, URL filtering for blocking bad websites, WildFire for analyzing unknowns, work the exact same way. They use the same threat intelligence and the same inspection techniques regardless of which platform they are running on. So, if you create a policy that says, decrypt and inspect all web traffic, and block any detected malware, that policy will be applied consistently. If a user in the office tries to download a virus hidden in an HTTPS file, the Strata firewall will decrypt, inspect, find the malware, and block it. If a remote user connected via SASE tries the exact same thing, the SASE service will decrypt, inspect, find the malware, and block it in the identical way. This consistency is very important. It simplifies managing security because you don't need different rules or processes for different parts of your network or different types of users. It ensures that your security posture, how you protect against threats and control applications, is reliable and uniform across your entire organization, whether using traditional firewalls or modern cloud-based security.